Cepheid Variable Stars. Cepheid Variable Stars is one category of variable stars. Variable stars mean that they vary in brightness, and typically the ones that we use to measure distances, they vary in brightness at a regular rate. So it turns out there's two categories of variable stars that we can use to measure distances. And the first one we're going to look at are the Cepheids. The Cepheids were figured out by this lady, Henrietta Leavitt. She was one of Pickering's women, that same group that led to Annie Cannon. Also led to Henrietta Leavitt becoming a professional astronomer. And she was studying stars in a nearby galaxy. And what was nice about that is that they were all the same distance away, since they were all in that same galaxy. So issues of, well, is that star really bright or is it just closer than the other star, are erased when you're looking at things that are all the same distance away. So she could tell which stars were truly brighter and which ones were truly fainter because they were all the same distance away. And what she found was there was a relationship between the period, that is, how long it took that star to go from bright to faint back to bright again. That's the period. And how bright that star actually is, the luminosity. And she was able to graph it. And this is a simplified version of her graph, but vertical scale, luminosity, horizontal scale, the period in days. So how long it took that star to go from bright, it's a G, to faint, back to bright, that's one period in its variability. And so, some stars only took one day to go from bright to faint to bright. Some stars took 6 days to do that. And the general relationship she found was the longer the period, that is, the longer it took for that star to get back to its original brightness, the brighter the star was. And that's what this graph is showing. So here we've got stars that are a short period and faint. Here we have stars that are a long period and bright. Later, she was able to actually quantify the brightness, get actual numbers associated with it. And that means that if you look to see how long does it take that star to go from bright to faint, back to bright, the observed period, you can then get the absolute magnitude. And all of these distance techniques that don't use parallax ultimately come down to the same thing. You need to know the absolute magnitude to find out how far away that star actually is, because you can compare it with the apparent magnitude to get the distance. Recall, if the apparent magnitude is represented by little m and absolute is represented by big M. In this case, if the apparent is brighter, then we know its distance is closer than 10 parsecs. If the apparent and absolute are equal, then we know it's 10 parsecs away. And if the apparent is fainter, we know that it's farther than 10 parsecs. So by comparing the apparent and absolute magnitudes, we can get the distance to the star. And since the period of variability gives the absolute magnitude, and the apparent, we just observe. That's how bright it looks in the night sky. So apparent's easy. You look up, you can determine the apparent magnitude. Absolute is always going to be the tricky one. And so in the case of Cepheid variables, our trick to get the absolute magnitude is the period of variability. And once you know those two values, we can determine how far away is that star.